Hello friends, welcome to DEKB7QHC. That's me, Richard Clark, KB7QHC, and I'm going to follow on my discussion of how to get into the hobby at a very pacing your outlay in cash to suit the minimum needs that will bring you a clarity as to if your choice of engaging in ham radio is correct for you. So earlier I mentioned that you might lay out $70 for a good shortwave listening rig. DX440 was one that I offered. There's lots of others, and I've even had a little $40 shortwave rig, again from Radio Shack. It works fine too, but it didn't meet my requirements for having an antenna connector, except to put an alligator clip on the whip. That works too. It makes for a great survey radio if you use it to walk around the house and to find a interfering signal. And yes, they're out there. We'll be talking about that at great length in another episode, but this is about getting in for cheap. This will probably be another $70 outlay, and you don't need it immediately, but you might want to think about it first rather than last, and that's batteries. Now, what do I mean by batteries? What does C-cells, D-cells, AA's, AAA's? No. I'm talking about the big stuff. Lead acid, but a gel cell is what they're called, and they're sealed. And they provide a lot of current and a lot of voltage, well, 12 volts. And 12 volts is a very common voltage specification for much of the electronics in our hobby. And I would suggest something, if you're going to buy a power supply to do the work of the battery, you're going to need at least a 30 amp power source, and I mean 30 amps, keyed down, walk away, come back, key up. In other words, very long-term service kind of situation. Batteries can do that for maybe an hour, maybe 20 hours, depending upon how heavily you use them. We'll get into that later. But the power supply that you use for your equipment, and you're going to need a power supply, almost nothing in the amateur radio field plugs into the wall, and it's not plug and play by any stretch of the imagination. So we need to talk about this first, because you may not be aware of that if you're just entering the field of amateur radio, or you're new to the makerspace. So 30 amp, 12 volts guaranteed. You'll often see that the rig that you buy says, "Oh, you only need 20 amp supply." No, that's working with mirrors and fog. No, 30 amps. I can go into the current demands of a transmitter or a transceiver, the principal efficiencies between the various classes of emission that we have available to us, like CW. It's very efficient. That's typically in the 70%, 80%. But when you get to talking on it, that plunges to maybe 40%. There's some bad equipment out there, 40%. Most will stretch it up to about 48, 49, maybe 54. Somewhere about half. And this should come as no surprise to the older, more practiced people that are watching this. But I'm not going to go into the arguments over source resistance and such and matching. We'll do plenty of matching later, but we're just here to talk about the power supply. And the power supply, okay, 30 amps, 12 volts. However, battery or power supply, make it a switcher power supply. In other words, something that's small. 20 amp, 30 amps, 12 volts. That's a 400 watt kind of big frame power supply from back in this era. But in our current era, little switchers can achieve those kinds of power densities without breaking a sweat. So, of course, they cost a little more. 30 amps, 12 volts from that or a battery. That'll probably cost you about $100, probably less. When I go into the discussion of power for your rig that you eventually buy into, we'll examine variations on that theme. But you might anticipate that if you do go for the battery, you're also going to need something to charge it, and we're back to that power supply again. So the recommendation here is the power supply be able to supply 30 amps up to 15 volts, not 12, 15 or higher. But higher generally means more expensive, and unless you have a rig whose final is separately powered from the rest of the transceiver, you can get up to 50 volts. A lot of the power transistors in the older rigs from the 70s, 80s, they can manage a 50 volt supply. Well, 50 volts compared to 12 volts, yeah, that sounds like quite a deal. It can be a flamethrower too, because we're not talking about a 100 watt rig anymore. We're talking probably in the order, well, let's see. Let's say if I quadruple it, the power goes up by the square. That's 1600 watts. I don't think so. So even though the transistors can take a 50 volt supply, that doesn't mean they can supply all the current or supply the RF that's in a power level that's suited to that 50 volt rail. But like I said, these are future choices that if you anticipate them now, it's cheaper now than it is later. Believe me, yes. So, and again, why I say 15 volts instead of 12 volts for this power supply is that you need to charge the battery. And the battery technology is such that you use what's called a float charge. And the float charge doesn't need the 30 amps from your 15 volt switcher power supply. No. But if you have a 15 volt 30 amp switcher supply, charging the battery, floating it, this is just maintaining enough current to keep its cells charged, 98, 99, 100% level, sort of floating in there. Then you can run your rigs and all your equipment off the power supply, and you have the additional, these are in parallel, of course, as your transmitter will see them. That means you have have a very high current capacity at least 12 volts. High current capacity can't hurt you at all. So, think in terms of a battery, sealed lead acid gel. Good ones. There's a certain brand out there. Let's see if no, I don't. I'll suggest brands later. American made, bulletproof, is in every hallway that you've walked down. These batteries are in every application in the hallway for emergency lighting. So they have a service life that's out in the years. And you might even be able to find them for sale surplus, used batteries. You might say, well, if they're not going to use them anymore, why should I? Well, they'll be cheaper for one. We're talking about expense. You might have a battery that was formerly rated at, let's say, 100 watt hours, and it's been degraded to maybe 40 watt hours. Okay. But in the initial runs of you feeling out your space in the makerspace or ham radio world, 40 watt hours is going to be sufficient for you to experiment with and to see if you want to plunge for a brand new battery or some other option, because you don't really need a battery. But we have field days, and if we're going to need to get into connectorizing all of this, and if you connectorize this right, the battery goes with you, and you get full service from your rig. If you connector it wrong, it's going to make field day is going to be more about making connections than actually operating. And, well, I would find pleasure in that, but I don't need to do it, so, and I don't want to wish it upon you. So we're going to talk about connectors later, and I'm going to drop a little hint. These are going to be massive contact, face-to-face contact plug methods that you'll find in the forklift arena. And they sell mating connectors that can full service, oh goodness, 50 amps, 100 amps, no problem. So investigate the connectors from the forklift industry. I can't think of the names, but again, a little research, and we'll touch on this again, I promise. So there we are, one step at a time, a radio and batteries and connectors. We'll get to the connectors in future episode. So I'll extend my 73s to you. See you later. Hope to see you soon.